Welcome back. Thanks for watching this second video. So this will be problems 29 to 31. So let's read the problem. It says two functions f and g are represented below. So we have f of x in a table, and we have g of x on the graph. And we need to compare the statements in column A and B. In the empty space at the end of each row in the table, write the column letter A or B of the expression that has the greater value. So basically, which is bigger, A or B? And that's our answer that's going to go here. If both expressions are equal, write an equal sign. So we need to start evaluating. And in the other video, I had suggested writing f of x on top of the f of 1 so that it helps you see that x is equal to 1. So if our x is equal to 1, we're going to go up to our table, make sure that you're looking at the right function. So if I'm given f, I need to look at f, and if x is 1, then f of 1 would be 2. So column A is 2, and then we need to check column B. So this is g of negative 3, g of x, so our x is negative 3. If x is negative 3, I'm going to go to g function, go back to negative 3, so this is our x-axis, back to negative 3. Our g of negative 3 would be 1. So which one is larger? Well, column A is larger. Alright, so hopefully you guys have already tried this. If you haven't already tried it, you want to hit pause and try it, then hit play again. Alright, so maximum value of f. So I want to, well, which one's the biggest? Looks like, you might be tempted to say 10, but because that's a negative 10, it's not the biggest, it's the smallest. So we want to go with 9. 9 would be the largest value of f, and the x-intercept of g. So where do we cross the x-axis? It looks like at negative 2. So which of these is larger, 9 or negative 2? Again, column A is greater. Alright, now we have a couple things we need to do. F of 0, f of 4. So again, this is our x value. F of 0 is 8. F of 4 is 0. So 8 minus 0. Take nothing away from 8, and you still have 8. And that would be 2. Over here we have g of x, so g of 2. If x is 2, where is our function? Down here at negative 3. And then we need to multiply that to g of 4. 4, we're at negative 2. So if I multiply negative 3 and negative 2, I get a positive 6. So which is larger, 6 or 2? Well, 6 is larger. Alright, the next one is asking the value of x that makes f of x equal to 0. So here we're saying the output is 0. What was the input? So if the output is 0, what did we input? We input a value of 4. So what value of x? At x equals 4. And then here, again, negative 5, g of negative 5. So we have to ask ourselves, is that the x or the y? And that is our x, g of x. When x is negative 5, 1, 2, 3, 4, 5, we're up here at 3. And it's asking us to add g of negative 3. 1, 2, 3. 1, 3 plus 1 is 4. It looks like now they are the same value, and they told us to write an equal sign. The last one, g of 4, 1, 2, 3, 4, is negative 2. And a plus b. If f of a is 5 and f of b is negative 10, so we need to find what input value got me 5, what input value got me negative 10, and then add those two values together. So how did I get 5? Well, to get a 5, I input a negative 8. So a is equal to negative 8. B, how did we get negative 10? We had an input of 7. So if I add up a 7 and a negative 8, I get a negative 1. A plus b, negative 8 plus 7 is negative 1. So compare, be careful. I might even draw a little number line. This is 0, negative 1, negative 2, to prove to myself that negative 1 really is larger than negative 2. So here column A is greater. Alright, I know that was a tricky one. So if you need extra help with that, go and see your teacher. All right, now we've got comparing two different options. So Callie makes a $60,000 starting salary at her new job. She's offered two different options for salary increase. We've got option A or option B. An increase in salary of $3,000 per year, or an increase in salary of 3% per year. So this one we're just adding 3,000 each year, and this one we're multiplying by 3%. We need to be careful with that. We're multiplying by 3%. Percent, if we break that word apart, we're dividing by 100. So if we take 3%, 3 divided by 100, our decimal place moves 2 places to the left, and we get 0.03. So we're actually multiplying by 0.03. But we need to be careful, because that is the increase. So if we say, okay, well, next year, is she only making 3% of her salary? No, she's making 3% more than her salary was. So we also have her initial salary, so we're multiplying by 1.03. All right. So let the function a of t and b of t represent her salaries after t years using option A and B respectively. So we need to complete the table. Okay, so 6,000 here, add 3,000, we're going to have 63,000, 66,000. Tried to make my pen smaller, didn't work. All right, 69,000. And on the other side, I might grab my calculator. All right, so if we take 60,000 and multiply it times 1.03, we're going to get 63,654. Then we multiply that by 1.03, and we get 6. Oh, I lied. Sorry. That was the second one. All right, let's try that again. All right, if we multiply by 1.03, we get 61,800. That was the second one. 63,654 and 65,563 and 62 cents. All right, so we need to complete the recursive rule for each of the options. And I think you guys were really good at this. This is saying we start with how much? We started with 60,000, and each time we took the previous term, and in this case we're talking about a of t, so here to say the term right before it, we would say a of t minus 1. So the term right before it, and then what did we do each time? Well, we added 3,000. So that would be the recursive rule. Over here, same starting value. We started with 60,000, but each time we took b, notice now we're taking b, the previous term, b of t minus 1, and we multiply it times 1.03. So I'm going to put that 1.03 in front times b of t minus 1. All right, so we take the previous term and multiply it times 1.03, and that would be a 3% increase. All right, the explicit rule, we're going to say, all right, what did we start with? We started with 60,000 and added 3,000 each time, and my variable here is t, so I need to use a t. In this one, we started with 60,000, and each time we multiplied by 1.03 to the t power, because this one we're talking about a geometric increase and this one is arithmetic. Here we're adding, here we're multiplying. A sketch, so I'm not going to do a very detailed sketch. This is just the general shape of the graph. So here we have a linear increase. We started at 6,000 and then each year it went up 3,000. Right, so this would be time, and this would be salary. And then here, same thing, salary and time. Started with 60,000, but instead of increasing linearly, it's increasing exponentially. So it's going to make that general shape. Okay? All right. I think there is one last problem to look at. So problem 31, look at the three sequences below. So we've got three sequences and we have to decide which of the above sequences is arithmetic. Sorry, I got cut off. I believe that's all it said. Let me check. Yes. Okay. So we have to decide, is it 1 only, 3 only, 1 and 3, or 1, 2, and 3? So let's start with 1. This is saying, is it arithmetic? We need to know that means we are adding the same number each time. I put plus D because it's adding a common difference. So we started at 45, and then we took the previous term and we subtracted, but subtracting and adding are both arithmetic. So we added a -4 there. So this would say, yes, it's arithmetic. Here we started at 45 and then decreased 4 each time. We are still arithmetic, right? Linear and arithmetic are similar. Here, they're asking us to figure out, well, let's see, 45 decreased 4. Oh, it's the same thing. Okay, -4, -4. So it continues in an arithmetic pattern. So it looks like the answer would be D. All right, thank you for watching these videos. That is great. All right, you're going to do wonderfully on the final exam, but you need to study.